So, what do we know? Let me start over since we're at the beginning. Talking about the mean value theorem, our goal today is to find where the average slope equals the instantaneous slope. What do we know about average slope?
You mumbled, I don't think we could catch on that.
Not repeating it one more time.
Average slope.
What is average slope? We should.
Minus f of a divided by b minus a.
Thank you. Hopefully this is being beaten into your head.
Average.
You will need to know.
Actually, do
I can say estimate slope to also ask you to find average slope. Estimate the value. Say that.
It freaks me out. It's the white screen of doom.
What does instantaneous speed mean? Or instantaneous slope?
Slope is derivative.
Derivative, or f prime, or just slope.
Prime. TDX.
Mr.
Yep.
Government
So
agent
many
that's like
Ts.
stalking me.
There are.
Stop it.
You realize we're recording, right? Just saying.
Who's gonna see it besides us?
I did have some random person post like a comment. This was such a great lecture. I'm like, how did you even find this?
Oh my gosh. Oh my gosh. Really? Yeah. Homer? The first impression's like, I have no idea. And then he just smiles for a minute. He was like, I say that again. Yeah. It's for that movie. It's at 600,000 views. Which one? It's a demonstration and because it was like the helium, but then he just talks it with the luminance.
Okay, that would be like totally creepy if the screen did turn off.
Okay. So, here's a visual representation of the mean value theorem. We're trying to find where the average slope equals the instantaneous slope. So how would I find the average slope visually on this graph from A to B? What do we might mean by these average slopes and these instantaneous slopes visually?
Do you want the numbers? Sure, are the numbers important on this graph?
No, the numbers are not important on this graph. I just did a standard plug it in. I think I can turn those off. Yeah. Come on. Let me do stuff. Fine. I hate you smart boys.
You realize we're
Ha!
recording, right?
As long as I don't say I hate you students, then I think we're good.
Jeez, you realize we're recording, right?
That was an example of things I wouldn't say.
There is a thing of sarcasm.
So, visually, how do we find slope of something? Because we can't find slope of a curve, but what's the only geometric shape we know how to find the slope of?
A line.
A line. So if I want to find the slope from A to B,
We draw a line.
we draw a line. Since I suck at drawing lines.
That's a beautiful line. It has 4 points. Something tells me this lecture's
Huh.
going to be really fun to listen to.
Oh, yeah.
Half the time you can't even hear us.
There we go.
Yeah, they're really quiet.
Okay. So that line represents slope between the 2 points A and B. Now since it's between 2 points, what kind of line hits 2 points instead of 1 point? Secant line. So this is a secant line. That is the secant line. So our goal is to find where on this graph is the tangent line that same slope. Where are the two lines parallel?
I
In the middle.
see.
So
So perfect.
if I copied this, I thought it would come out with the same tilt.
It is.
Okay, woo, looked weird. Then we're trying to find the value where this, like I couldn't just place this line anywhere. I couldn't put it here. It has to be at that one value. We'll call this value C. Has to be on that one value where those slopes would end up being parallel. So some of our goal is to find what is that one value? Where would these slopes be parallel? Now it's possible, what if I had a graph that looked a little bit different? What if I had a graph that looked like this? So it is possible to have two values. I could go here, or I could go down here. Or it's possible to have 3 or 4 or 5.
Whoa, let's
But-
slow down here.
What we're guaranteed is at least one value. So we're guaranteed at least one value, and we have some requirements for this theorem to work. We must be continuous. No holes, no jumps, asymptotes, oscillations. And those are the 4 for continuity. And we must be differentiable as well. So what else is now a requirement? No cusps. That is the only way that this will work, this theorem. If our function is discontinuous or our function is not differentiable anywhere on our interval, we cannot apply this theorem. It must follow those requirements. So here is the more, so that's the general geometric pictorial understanding. This is the actual mathy mean value theorem, which is also important to see because on the AP test they write things in a very mathy way. So if y equals f of x is continuous, there's our first requirement, at every point of the closed interval, and that's actually a good idea, Evelyn. We should put this on a note card. That was Emma. Okay. I just do not give you enough credit, Emma. I saw Evelyn's note
I
card
was like,
now.
oh, we should get our note cards, and Evelyn did it. And I just continued to write.
So, and differentiable at every point of its interior a comma b, then there is at least one point C in AB at which f prime of C equals f of b minus f of a over b minus a. So, again, the mathy way is still just saying the same thing we did with the picture. It's saying the slope of the secant line, this being the secant, should equal the slope of the tangent line somewhere, as long as we fit those requirements. So let's look at an example. Again, these need to be on an interval because we can't find a secant line unless we have 2 points. So when I say 1, 4, even if I had brackets on those, it would still be considered both x values. This is an x1 and an x2. Because I said on 1 to 4. Or they would say interval somewhere in the question, on the interval 1 to 4. So that is not an x comma y coordinate. It's 2x values. So we have 5 minus 4 over x. We want to know where the instantaneous speed equals the average speed. So let's start by finding average speed. What did we say average speed was?
Isn't it f of b minus f of a over b minus a?
F of b minus f of a over b minus a. What's a and what's b? A and b should be x values, according to our picture.
1 and 4.
You look at our picture, they're x values, so 1 and 4 are a and b. Usually we make a the smaller one, b the bigger one. So we would find f of 4 minus f of 1 over 4 minus 1. And we know how to find those values, that's easy, we just plug it into the function. So f of 4 would be 5 minus 4 over 4 minus, anytime we have a minus sign we have to put the rest in parentheses, f of 1 is 5 minus 4 over 1, all over 4 minus 1, and then we just simplify. I'm going to shut the door really quick.
I think that made it in that box.
So we do 5 minus 1 minus 5 minus 4. So this all together would be 1. 5 minus 1 minus 1 is 3.
Oh.
5 minus 4 divided by 4?
Yeah, order of operations, we do the division first because this was 4 over x.
Right. And so that's just 5 minus 1.
Yeah,
Yeah.
which is 4. Minus 1, which is 3.
Okay.
So we get 1. So our average speed, we usually say average speed is like delta y over delta x. That's another way to write it. Average speed is 1. So how do we find instantaneous speed?
Derivative.
Derivative. So I can take the derivative of this function. I can find f prime of x. Derivative of 5 is 0. 4 over x, how could we rewrite that to make it easier to take the derivative of?
4x to negative 1.
So we get negative 4x to the negative 2 as our derivative. Now, that average speed, is that our x value or is that our y value?
Wouldn't it be positive because it was 5 minus 4 over x?
Thank you. Yeah. Sorry, I couldn't see the function anymore, so. Okay, is the average speed an x value or a y value? When we find speed, what's, we're finding speed over time, right? So time is always our x values, and speed is always
Why though?
our y value. So we don't know what x is. I can't just plug in a number for x because x is really our time. But if I do know a y value, how could I find x if I know a y value for f prime of x?
Plug it in for f prime of x.
Plug it in for f prime of x. So if I say 1 equals 4x to the negative 2, I can solve that equation and get my x value where that speed occurred. And again, they can ask a lot of variations. This one is just finding that c. Where does the actual speed occur?
I have a quick question. What is that in front of it?
That's a plus sign.
Oh,
Oh, yeah. It's because I wrote negative and it was really positive.
Now it looks like it's scribbled in 3.
So we solved this. How do I solve this?
the 2 is 2 and 4 next to
Divide by 4. We can't solve while that's a negative exponent. So 1 over x squared. This is fun. If we have fractions on 2 sides, split both sides.
Wow. You can do
Yep.
that.
And I dropped the 1's off because 4 over 1 is 4 and x squared over 1 is. It's just a quick version of cross multiplying. Just flipping both
Dang
sides.
it is.
And then we square root.
What is it?
What is the square root of 4?
8.
Is it?
It's 16. No,
Plus
no,
or
it's
minus.
Plus or minus 2. Okay? But we did have an interval at the beginning. We had a restricted domain. Our domain was not the entire function. What was our interval from the beginning?
1 to 4.
1 to 4. So which one can we get rid of?
No, negative.
The negative 2. So our x value is 2. That's the x value where the instantaneous slope equals the average slope. Now, this is not the most common question on the AP test that they would do for MVT, for mean value theorem. So we're going to do 2 more examples that are kind of variations of this concept.
So you just have to find that x equals 2 and that's it?
Yes, that is the x value where the the instantaneous slope matches the average slope that we found.
Alright, and why doesn't the negative work?
The domain.
It was not on the interval. On the beginning, the interval was... Okay. This is something that they would be more likely to ask. And then our third example is what they would be most likely to ask.
But if you want to get a 5 instead of a 3,
Should make like a poster. My awesome sayings. So, find the equation of the secant line and the tangent line parallel. This time we're actually finding the equation of a line. So what equation do we know we have to use? How do I find equation of a line? 1, 2, 3. Evelyn, go.
Slope. Point slope.
And what is point slope? Yes. Okay. Anytime we see the word secant line, tangent line, that equation should pop into our head. Secant line, tangent line, we need that equation. So right now, again, that's an interval, not a coordinate. So right now, all the information I have is x values. These are only x values. We need to find y values and slope. So, first we need slope of the secant line. How do we find slope of the secant line? Derivative would be slope of the tangent line.
F of B minus F of A over F.
So F of B minus F of A over B minus A.
F of b minus f of a over b minus a, so f of 3 minus f of negative 1 over 3 minus negative 1. And this is a, this is b. We can plug that in. If we plug in 3, we get 27 minus 18, which is 9, plus 7, so 16.
Sure.
If we plug in negative 1, we would get negative 1 to the third is negative 1. Negative 1 squared is positive 1, so negative 1 minus 2 is negative 3, plus 7 is 4. So 16 minus 4. You don't have to do it that way. You could write it out though. You know?
long way.
Yeah, we could do 3 to the third, minus 2, 3 squared, plus 7 minus
So these are
blah, blah, blah,
where did the
over 3 plus 1. So we get 16 minus 4 is 12 over 4, which is 3. So this is the average slope. This is the slope of which one, secant or tangent? Secant. Well, it is the tangent line parallel, so yes, both. You are correct. But right now we're just focusing on secant. So we have an x value, we have a slope. How am I going to find my y value? Plug x back in. Well, I have 2 x's. Which x do I use?
Doesn't matter.
Does it matter? Let's check. What if I plug in 3? When we plugged in 3, we got 16. So we had y minus 16 equals 3 times x minus, nope, x minus 3, sorry. I was doing the other one as well. So that's if I plugged in 3. If I plugged in negative 1, I get y minus 4 equals 3 times x minus negative 1, which is plus 1. Are these the same thing? How would we find out if they're the same thing? multiply it out, simplify. If we distribute 3x, we get 3x minus 9. If we add 16, we get plus 7. If we distribute, we get y equals 3x. 3 times positive 1 is 3, plus 4 is 7. So, did it matter? Nope. Didn't matter which point we chose for the secant line. So then we have to consider the tangent line. So this one was the secant line. Now let's consider the tangent line. What information do we know about the tangent line so far? Something Emma pointed out earlier. It has the same slope. Currently, that is all the information I have for the tangent line. I know the slope of my tangent line is 3. So we know slope is 3. What else could we find about slope? If we have a function, sorry, I hate to do this, but if we have a function up here, what do we know about slope?
It's the derivative.
The derivative. So we know f prime of x is 3x squared minus 4x. So if we know the derivative is that, and I know the slope is 3, set it equal? Solve for x. You're both correct. Now, 3x squared minus 4x equals 3. I could, again, do quadratic formula if I got it equal to 0. I possibly could factor, but as Emma and Melinda are doing, we can use our calculator on this one. Something like this would probably be calculator active, unless it factored nicely, then it would not be calculator active. But if it doesn't factor nicely, which this one would not, then we have to go to the algebra button, right, and the solve. So what did you get, Melinda?
I got x equals negative square root of 13 minus 2 over 3.
Like that?
Oh, the whole thing over 2.
Okay.
And then I got or the positive.
Or plus.
Yeah.
So the plus would be,
So it's positive and then there's a plus 2.
if there's a plus 2, not a plus
Yeah.
square root 13. I
Yeah.
believe you, I would have expected the plus to be in front of the square root 13.
Well, it's it's positive.
All positive or all
Yeah.
Oh, okay.
So it's both.
Okay. Do we really want to work with these values?
No.
How can we get the decimal versions using this calculator? Control Enter instead of Enter. So let's get the decimal versions.
It's negative 0.535184.
1, 8. We just need 5, so I'm going to stop at 1, 8. You can always do more.
And 1.86852.
1.86852. So those are our possible x values. Which one can I throw out? I believe I can throw one out. Why can I throw out the negative 0.5?
It's not in the.
It's not in the interval.
Yes, it is.
Wait, yes, it is.
Oh.
Negative
Oh,
1
it's
to
negative
3.
1.
Negative 1 to 3? Then we're going to have to do 2 tangent lines. There's 2 x values, we can do 2 tangent lines. So how do we find the y values that go with these?
Plug them in.
Plug them into f of x. So we want f of negative 0.53518. And we want f of 1.86852. Now the reason we have to do both is because even though these tangent lines have two slopes, or the same slope, they're going to be in two different positions. So they will be different actual equations. So if we plug these in, I think there's a way, I'll show you next time because we're running out of time. There's a way you can actually plug in the function itself, like x to the third, and
And
just
then-
say
Oh,
that would be
evaluate
so
at.
nice.
So much easier.
I'm pretty sure this calculator will do that. I just need to know the correct input pattern. So. Does anyone have?
7.41.
That is not.
Did I do it wrong? Did I do it wrong?
So did I.
Okay, so we have two people who got 6..
27387.
Again, we still need 5 because we're still going to plug this into the tangent line equation. And then we would need 5 on this second one.
Oh,
6
96.
point.
54096.
Did anyone else do the second one? Same thing? Okay. So then we could write the equations of our tangent lines. This time we're not going to simplify them because we're running out of time. We would do y minus 6.27387 equals 3 times x minus a negative. Make sure you're using the x associated with that y value, so plus 0.53518. We could simplify, we're not going to, because again, we're almost out of time and I want to do this last example really quick. Y minus 6.54096 equals 3 times x minus 1.86852. So just plugging them into point slope form, which we've practiced quite a bit. Usually the plugging into point slope form is not the problem, it's recognizing we need to use point slope form. So we have one last question, then I'll show you the homework. We won't have time to work on our assignment today. Does everyone have this written down before I move on?
Please try to write a new page this time, 'cause I always split up my problems.
Okay. A marathoner ran the 26.2 mile New York City Marathon in 2.2 hours. Show that at least twice the marathoner was running exactly 11 miles per hour. I don't know. I just stole this from the book. Is that a really, really good time?
Well, I was helping at the Salt Lake Marathon, and the guy in first place was an hour and a half halfway.
Huh?
So that
So-
would be 3 something. This
Huh.
guy ran it in 2 something.
You try and run 11 miles an hour and finish 1 mile.
Hmm.
I know you can do it.
2 hours.
I can't run like 2 miles an hour for just 1 mile.
It could do it. And I've been training.
Okay,
Most people can run.
so he's really, really fast. How can we find his speed? How can we find his average speed? Because I can't find instantaneous unless I have a function. How do we find speed of anything normally in physics? Velocity is distance divided by time. So if I took this distance, 26.2, and I divided by time, we get like 11.8, I think. Someone want to plug it in?
11.909.
1.9091. So this would be miles per hour. This is his average speed. So we know at some point his instantaneous speed was 11.9 miles per hour. That had to happen. At some point he reached 11.9. So if he had to reach 11.9, what value would he have to go through to get there? 11. Well, then eventually he stopped running, I hope. So when he slowed down to stop running, what value did he have to eventually pass through? 11 miles per hour. So we call that the intermediate value theorem when you're saying, well, he had to pass through this value on the way there and had to pass through this value on the way back. So we would make the statement by intermediate value theorem, blah, blah, blah. But we're running out of time, so I want to make sure you get the assignment before you go.
That's super important. Like stopping the